Thanks, Doug. Speaking very quickly there, but everything was very clear. That's great. And we're now on to our last speaker, which is Martin EUGSTER. That's close? Who's project manager for the Swiss Federal Laboratories for Materials Testing and Research. And he's going to talk about environmental and climate change issues relating to the technology within the boxes, essentially. Okay, thanks.
Thank you. So, well, my name is Martin EUGSTER, as introduced, and I'm working at EMPA. EMPA is a research institute on material science and technology. In our lab, called Technology and Society Lab, we basically analyze and assess positive and also negative impacts on the society generally. One important aspect, of course, are the environmental impacts. I would like to talk within the next 10 minutes about environmental impacts of ICT products and present you an LCA study on desktop PC systems carried out within a project in China. So generally, we have already discussed this issue. One can say society is overusing the services provided by nature. And the question is, what is really the role of ICT? On the left side, we have ICT is part of the solution. We discussed this that morning. I will focus on the other side. So ICT is also part, to some extent, of the problem. So if we talk about a life cycle assessment, the life cycle can be divided into three main phases, so production, use, and end-of-life phase. And you can see on the left side, resources are used, and of course, residues or waste is generated, and very important streams are these back streams are the recycling of products. So a few words about the methodology we have applied. So it's a classical LCA. So it's a methodology to estimate environmental and impacts. So it's basically there are two steps relevant. So first, input-output analysis carried out in order to analyze a functional unit or a system, whatever. That means that all kind of data have to be collected, what's really the amount of CO2 emissions, for instance, or other pollutants. And in a second step, assessment of each single environmental impact is carried out. So the functional unit in this case was a desktop PC system produced in China. So we carried out this study together with a local partner, with MOFCOM, that's the Ministry of Commerce in China. And interestingly is that this ministry is very much concerned about sustainability issues and carried out several sectoral studies, one on forestry, cotton textile, and the third on electronics. And this was part of this project. So this functional unit contains a PC, including a CRT or an LCD screen. And these products are produced in China, but of course, distributed globally, and assumed was a lifespan of 6 years. So that shows you only very briefly the system. There a lot of data is needed. So one part of the data is gathered within the scope of the project in China, in the Chinese context. Others are adapted. And to a large extent, of course, a database was used. This database is called EcoInvent. That's an inventory database which has been, a few months ago, also extended its content to electronic products. So I will present you the main results. In China, in 2005, more than 80 million desktop PCs were produced. In the production, about 45,000 gigawatt hours of energy was consumed, and annually 18,000 is on average conditions consumed. Looking at end of life, there is a potential that 20 to 25 of this energy can be saved, mainly, of course, by avoiding primary production of the metals of the products. If we look at greenhouse gases, that's the matter of interest of this session, of course, we can see the following picture. Along the life cycle, that's also per unit, per functional unit, meaning a PC desktop computer system, close to 600 kilograms CO2 are emitted in the manufacturing phase. Nearly neglectable is the distribution phase, all the transport, and in the use phase, in the 6 years, more than 1,200 kilograms equivalent. That's not only CO2, also including other greenhouse gases, is emitted. The negative figure in the end-of-life phase indicates, assuming state-of-the-art technology, that recycling can occur environmental benefits. However, greenhouse gases are important, but I also want to say a few words about other relevant environmental impacts. That's the picture of all accumulated environmental impacts weighted in eco-indicator points, meaning that indicates the pollution level. And we can see that about 5, or depending on the case, 10–15% of this total accumulated environmental impacts result from greenhouse gases. If you focus to the manufacturing side, you can not read it, but we can a little bit zoom in. It's interesting to see that in manufacturing, most of these environmental impacts or loads occur in the production of wafers, integrated circuits, or finally the motherboard. We see here on this graph that about 54% of the environmental loads in a PC occur in the production of the motherboard. If we compare it, the production was also subject of this project to compare it with other devices. We see that air conditioner and also fridges have a higher environmental load, mainly because these are heavier devices and consume more material. If you look at the annual environmental impacts in the use phase, that's annually, we see that the highest impacts are generated by the air conditioners and fridges. Of course, this is due to the fact there are different consumption patterns of these devices. I highlight only a few things due to the importance to e-waste. We assume it's a key problem in the ICT discussion if we talk about environmental impacts. And there will be, due to not yet saturated markets, mainly in emerging countries, a continuous and also dramatic increase of e-waste volumes. If you look at China or India, for instance. So that's the figure in Switzerland. We see here in the gray bars indicate the imports. We do not have any producers in Switzerland, but the imports of ICT products. And also in Switzerland, we have still increasing waste volumes, e-waste volumes from ICT products. If you look at the material composition, we see more than 60% are metals, so with a high intrinsic value, so recyclable, very valuable. But we also have only 0.8% of hazardous fractions. But of course, in terms of environment, these are very irrelevant fractions. If we think about CFC, that's also an issue in the climate change discussion, of fridges or air cons, it's a very important part, or mercury in backlight tubes of LCD screens, and so on. If you look at the elements in electronics, we know there are about 57 elements can be found in electronics. That's very interesting. And of course, we also know that some of them are critically scarce. I think indium in LCD screens or others. So e-waste recycling is important. There are some pictures, or a picture in China. So we can either reuse functions, prolong lifetime, entire appliances, or only some components. And of course, we can reuse or recycle finally the material. Also here in India, precious metals recycling, copper recycling. We also discussed a little bit, mainly carried out in informal businesses. Of course, if we talk about societal impacts, it also creates employment. That's plastic sorting in India or in China, disassembling of devices. Or it can be dangerous, sorry, if components are desoldered from printed circuit boards. But by the way, it's very inefficient. If you recycle circuit boards in metallurgical processes, you have a much higher yield, of course, than in informal processes. And finally, it's polluting. We have water pollution, we have emissions to air, and so on. All these are very important environmental impacts and account for the other 90% of the overall environmental impacts in the life cycle. So to wrap up the findings, desktop PC production, the share to 1 year of use is about 3:1 for energy and 6:1 for the aggregated environmental impacts. 5 to 15% of all our overall environmental impacts result from greenhouse gases. Recycling clearly pays off in environmental terms, but also economically, by the way, as these metals are recovered and energy is saved. And, of course, we have seen substantial concerns regarding health and safety risk in the informal recycling processes can occur. So the ICT life cycle problems are global, and emerging economies are particularly affected, again, if we think at the growth in India and China. Thank you. I can also announce, by the way, a new book which will be published end of this month by our head of our group, Professor Hilty, also dealing with this issue on information technology and sustainability. Thank you very much.